So, hello everyone. So, today we'll discuss Greeks. Now, this is one of the important topic in derivative, and this topic you will encounter in CFA, you will encounter in FRM, you will encounter in your MBA Finance. Any finance related curriculum, you will encounter this topic, and this is one of the most, I would say, advanced topic in finance. However, not that difficult. So, first of all, understand that what are the different terminology you will understand in Greek. Apart from that, disclaimer, this is a revision video. This is not a detailed video of Greeks. Definitely, we'll try to cover all the nuances of Greek, but this would be too fast. It's not the normal session of CFA or FRA. We'll give sufficient time to each and every component of the topic. Okay, so the first term that we have to understand in Greek is delta, then gamma, then vega, rho, and theta. We already know and discussed in other session that the value of option is dependent upon multiple factors, that is stock price, exercise price, risk-free rate, sigma, which is volatility of the underlying asset, which is the stock price, and the time to maturity. So the value of any option, whether it is call option, put option, or any other option on the planet, is dependent upon stock price, exercise price, risk-free rate, sigma, and time. Now, if we talk about the Black-Scholes-Merton model, then it also says that the value of a call option is S0 into ND1 minus X upon e to the power RFT into ND2. Now, D1 is equal to log of S upon X plus RF sigma square upon 2 into T upon sigma root T. So you can see that the call option is dependent upon stock price, it is dependent upon RF, it is dependent upon exercise price, it is dependent upon sigma, and it is also dependent upon time. So if any one of the factor changes, the value of the option changes, and the rate of change of option with respect to one of the factor keeping other factor constant is Greeks. Okay, so if I change the stock price and if the value of the option changes, I will call it as delta. If I keep other factor constant and just change the stock price and the value of option changes, the rate of change of value of option with 1 unit change in the stock price is called as delta. So the Greek associated to stock price is delta. Now, if I keep other factor constant and only change R if the risk-free rate and the value of option changes, the rate of change of option with respect to 1 unit change in risk-free rate is rho. Similarly, if I keep all the factor constant except vega and the value of call option or put option changes because of 1 unit change in the volatility, I will call the rate of change as vega, keeping other factor constant except volatility. Similarly, if the value of call option put option changes, if time changes, keeping other factor constant, and just 1 unit of time changing, that the rate of change of option due to 1 unit change in time will call as theta. So that is delta, vega, theta, and rho. What about gamma? We'll discuss about gamma in a while. But these are the first order derivative. The first order derivative of call option or put option with respect to the different factors. Okay, the first Greek that we have to discuss in length, and most of the time in the examination of CFA and FRM, the question would be asked from this Greek because it is easy to understand, that is delta. What is delta? Delta is the rate of change of option value due to 1 unit change in the stock price. The rate of change of option value due to 1 unit change in stock price keeping other factor constant. So delta of call, this is the symbol of delta of call, is the rate of change of call option due to the change of stock price, due to 1 unit change of stock price. Delta of put is what is the change in the put price with respect to 1 unit change in the stock price keeping other factor constant. And for a very small change, I denote it by what? dc upon ds, because it's the derivative. And for small change in the delta of the put, as in very small change in the delta of the stock, very small change in the stock price, I will call the delta of put, or I will write delta of put as the dp upon ds, differentiation. Okay. Now you should understand that when the stock price rises, we all know that the call price rises. So if there is a change in the stock price in upward direction, the call price will also change in upward direction. So the delta of call is going to be positive. Why? Because if the stock price is increasing, the call price is increasing. If the stock price is falling, the call price is falling. The call price is falling. When stock is increasing, call is also increasing. When stock is falling, call is also falling. So the change in stock price and the change in call price in the same direction. And therefore the delta of call is going to be positive. The delta of call is going to be positive, and the value of the delta of call is always between 0 to 1. Why 0 to 1? See, it is going to be positive, we understand. So the value of the call option, delta, the delta value will always be greater than 0. The delta call will always be greater than 0. But why less than 1? Because, understand, if I say in a very simple term that who is dad, who is son in stock and call, who is dad, who is son, stock is dad and call is son, and the speed of son cannot be greater than dad. Or another term, in a very theoretical language, if I say, then call has been derived from stock. Call has been derived from stock. So the speed of change of call cannot be greater than stock. So if stock changes by 1 rupees, call will change by less than 1 rupees. It cannot be greater than 1 rupees. It can never happen that stock price changes by 1 rupees and call will change by 1.2 rupees. No, because call has been derived from the stock. Okay. So the delta of call will always be less than 1 and greater than 0. Now let's talk about put. Now we know that if the stock price rises, put price fall. When the stock price rises, put price fall. We know that. And if the stock price fall, put price rises. There is an inverse relationship. So the delta of put is going to be positive or negative. Delta of put is always going to be negative. So delta of put is less than 0. We know that. But again, the value of delta of put, the the delta of put cannot be greater than, in the magnitude terms, cannot be greater than 1. Because again, in stock and put, stock is dad and put is son. Put has been derived from the stock. So if stock is changes by 1 rupees, put will change less than 1 rupees. It cannot be greater than 1 rupees. So the delta of put will be less than minus 1. Okay. Now in magnitude terms, you can say that the delta of put would be greater than 0 and less than 1. And in general terms, people say delta of put as 0.2. They will never say delta of put is negative 0.2, because everybody knows that the delta of put is going to be negative, because put and stock price moves in opposite direction. So in the question, they will say delta of put is equal to 0.2. Now it is you to understand that it is negative generally. So this is the market language. This is how market talk about delta of put. Okay. Now let's talk about the range of delta of call and delta of put. We understood that the delta of call will vary between 0 to 1, and delta of put, modulus of delta of put, vary between 0 to 1. However, if I respect the sign, then delta of put vary between minus 1 to 0. Okay. But how this vary? Where it is 0, where it is 0.5, where it is 0.6, where it is 1. If the call is in the money, then the delta of call will fall between 0.5 to 1. When call is in the money, call is in the money when stock price is greater than exercise price. However, when put is in the money, then the delta of put is between 0.5 to 1. And please, I'm not respecting the negative sign. It is you to understand the negative sign. And when put is in the money, when exercise price is less than stock price, right? When the exercise price is greater than stock price, or stock price is less than exercise price, then put is in the money. Add the money. When stock price is equal to exercise price, then the delta of call is 0.5 and delta of put is 0.5. When it is out of the money, then the delta of call is between 0 to 0.5 and delta of put is between 0 to 0.5. I am not respecting the negative term, but if you respect the negative term, this will become 0 to negative 0.5. This will become negative 0.5 and this will become negative 0.5 to 1. Okay. Now, Let's understand. Now this is the exercise price. Now this is the exercise price of a call. Say it is 1000 and the stock price is trading at 2 rupees. It is extremely out of the money. Extremely out of the money. Extremely out of the money. So if stock price increases by 1 rupees, by 3 rupees, the call value will change or not? It will hardly change. It would hardly impact the call price because the exercise price is 1000. So there is no change in the call price. Even the stock price is moving by 1 rupees. Even for 1 unit change in the stock price, the call price is not moving because it is extremely out of the money. So can I say the delta of call is equal to zero or very near to zero? So till it reaches at the money, the delta of call is very near to zero or fall between 0 to 0.5. Therefore, I've written out of the money call or put option delta is between 0 to 0.5 because the change in the stock price does not impact call or put price because it is out of the money. However, whenever it is at the money, there is a chance that it will become in the money, so it start impacting. Therefore, the delta of call is zero. Delta of call is 0.5 and delta of put is negative 0.5. Okay. Now, in the case of extreme in the money, for example, exercise price is zero and stock price is trading at 1000. If from 1000 the stock price changes to 1001, then there is a net profit of 1 rupees that you can see, right? And if you just respect the time value of money, still it is 0.999. Still it is, yeah, exactly 0.999. So you can see that the delta of call, the change in the value of call is very near to 1. So when it is extremely in the money, the call price is changing 1 to 1 with the stock price. So therefore, in the money, the delta of call is between 0.5 to 1 for both delta of call and delta of put. The delta in the money is near to 1 or extremely in the money, it is very near to 1, and in the money, it is between 0.5 to 1. So, so call is equal to S0 star into ND1, and S0 star is what? S0 upon e to the power dividend yield into time. So wherever there is S0, you convert it into S0 star, and S0 star is what? S0 upon e to the power dividend yield into time. Another way to calculate S0 star is S0 minus present value of dividend. It is only used when we have discrete dividend. However, in the case of BSN model, we assume that the interest rate or the dividend yields are continuous. So in this case, what will happen when you calculate the delta will not come to ND1 or 1 minus ND1. It will have another component, that is ND1 upon e to the power dividend yield into T. Because of the dividend yield, the delta of call value changes from ND1 to ND1 upon e to the power dividend yield into time. And the delta of put changes to from n bracket minus d1 to n bracket minus d1 upon e raised to the power dividend yield into time. So it was nd1 earlier, now it is nd1 upon e to the power d1 e to the power dividend yield into time. This was n minus d1, now it is n minus d1 upon e to the power dividend into time. So now if there is dividend paying stock, then the delta of call range is not only limited to 0 to 1, now it is limited to 0 to e to the power minus dividend yield into time, and here it is limited to 0 to e to the power minus dividend into time in the absolute term. Okay, now this is important. Now understand, the delta is not constant. We already discussed that delta value varies between 0 to 1. If it is out of the money, it is near to 0. If it is at the money, it is 0.5. It is in the money, it is near to 1. Right? We discussed this. So delta of call is not going to be constant. It is changing. Similarly, the delta of put is also not constant. It is also varying between 0 to minus 1. Out of the money, it is very near to 0. In the money, it is very near to minus 1. At the money, it is very near to negative 0.5. Now you can also plot the value of call for different stock price with the help of Black-Scholes-Merton model. To plot it, you will find this graph. This graph of call for change in the stock price. So see the stock price, I'm increasing the stock price from 0 to infinity, and here the call price. So I'm plotting call price against stock price. So you can see that the call value is changing. Okay. Now, what is the slope here? If you see the slope here, which is the tangent, this will be 0. When you calculate the slope here, it will come to tan 45 degree, and it will remain tan 45 degree beyond this. Tan 45, as the slope is going to be 45 degree, and the m, which is tan 45 degree, is what? 1. So slope is going to be 1. So you can see that the slope is varying from 0, and then it is increasing towards 1. So slope is changing. Slope is changing from 0 to 1. What is slope in this graph? This is change in call, which is C2 minus C1 upon stock price minus stock final minus stock initial. That is the slope. What is this? The change in call price for change in stock price. What is this? This is what? Delta. So slope is what? Delta. And the slope is varying between 0 to 1. Therefore, the delta of call is varying between 0 to 1. Extremely out of the money, assume this is the exercise price. Extremely out of the money, it is 0. Extremely in the money, it is very near to 1. Now, because the slope is changing, the delta is changing, the rate of change of slope is not constant. Remember the price yield curve of bond. The duration is not constant. So you calculated convexity. So the rate of change of the slope at different point, the rate of change of slope at different point in the graph of call versus stock is called as gamma. So what is gamma? Gamma is the rate of change of delta for change in the stock price. Stock price is increasing, the slope is changing. What is slope? Delta. So can I say the stock price is changing, the delta is changing? The rate of change of delta for 1 unit change in stock price. See, not call premium. I'm calling the change in delta due to 1 unit change in stock price is called as gamma. The change in delta of the call upon change in the stock price is called as gamma. So gamma is the rate of change of delta for 1 unit change in stock price. So it is a second order derivative very similar to convexity. So you can relate it as duration is the first order derivative like delta, and convexity is the second order derivative like gamma. So the rate of change of duration is convexity and the rate of change of delta is gamma. I'm trying to just build up the analogy. Similarly, if you plot the put with the help of Black-Scholes-Merton model, you keep on increasing the stock price, you will see that the put price will fall. Here, when you calculate the slope will come as tan 135 degree, which is minus 1. And here the slope will come as tan 0, which is 0. So slope is varying between minus 1 to 0. So slope is again changing. The rate of change of the slope is called as gamma again, gamma of put. But what is this slope? This slope is what? The change in put upon change in stock price. So basically what is the change in the put premium due to 1 unit change in the stock price? That is what? The delta of the put. Now this delta of the put is what? dp upon ds, and that is changing. The slope is changing. So slope is what? Slope of this graph is what? The delta of the put. So delta of the put is changing, and the rate of change of delta of the put is called as gamma. So gamma is change in delta upon change in stock price. Now range of delta. We discussed the range of delta for a non-dividend paying stock is between 0 to 1 for call, and range of delta for put is between minus 1 to 0 for non-dividend paying stock. But if it is a dividend paying stock, it will change from 0 to e to the power minus dividend yield into time, and for put again it changes from minus e to the power dividend yield into time till 0. You have to remember this. Now you also need to remember that gamma for call or put is always negative. See, we discussed the delta of call is always positive and delta of put is always negative. Why the delta of call is always positive? Because when the stock price rise, call price also rise. When the stock price falls, the call price also falls. They move in the same direction. However, in the case of put and stock price moves in opposite direction. Stock price rise, put price falls, and stock price fall, put price rise. They move in opposite direction, so delta of put is negative. But what about the gamma? What is gamma of put? See, gamma of put is also going to be positive and gamma of call is also going to be positive. Let's understand why. What is gamma? Gamma is the rate of change of delta of put because of 1 unit change in stock price. See, the stock price is increasing and you see the slope is moving from -1 to 0. -1 to 0. Here the slope is -1. -1 to 0. When you're moving from negative to 0, you're actually increasing. You're becoming positive. You're becoming less negative. So actually you're increasing. So when the stock price is increasing, the delta of put is also increasing. It is moving in positive direction. So therefore the gamma of the put is going to be positive. And here it is moving from, for call, it is moving from 0 to 1. It is easy to understand that when the stock price is increasing, the delta, which is the slope of this graph, is moving from 0 to 1, again increasing. So therefore, the gamma of call is also positive and gamma of put is also positive. So what is gamma? Gamma is the rate of change of delta for 1 unit change in the stock price. Okay. Now what is the interpretation of gamma if the gamma value is given as 0.02? It means that assume that the delta of call is 0.4 and the gamma is given as 0.08. This means that if stock price increases by 1 unit, definitely the delta of call will change, because we know that the delta of call changes from 0 to 1. It is not constant. But for 1 unit change in the stock price, if it increases by 1 rupees, the delta of call will become 4.08. However, if the stock price increases by 2 rupees, the delta of call will become 4.16. That is the interpretation of 0.02. Another important thing, why we are studying gamma? Because delta is only valid for a very small change in the stock price. Delta is not good if the change in the stock price is pretty high. Remember the discussion of duration and convexity. Even in the duration and convexity, we respect duration until unless the change in the interest rate is not too high. Similarly, in the case of delta, if the change in interest rate, similarly in the case of delta, if the change in the stock price is not too high, we respect delta. But if the change in the stock price is pretty high, we have to go to the second order derivative, which is gamma. Okay. Now, first of all, let's calculate the new call price if the delta is 0.7 and the stock price increases by 4 rupees. So it is saying that the delta is 0.7 and the initial call price is 2. So you have to find out the new call price given the delta is 0.7. What is delta? Delta is if the stock price changes by 1 unit, if the stock price changes by 1 unit, then the call premium changes by 0.7 unit. Okay. Now the stock price increases by 4 unit. So it increases by 4 unit. Then the call premium will change by 0.7 into 4. For 1 unit, the change is of 0.7 in the same direction because delta of call is positive. Now for 4 unit, it should be 0.7 into 4, that is 2.8. Earlier, the initial call price was 2 rupees. Now the change in the stock price is of 4 rupees. So the new call premium would be initial plus the change, sorry, that is 2.8, that is 4.8 rupees. So the new call premium is going to be 4.8 rupees. So I just did delta into change in stock price is actually the change in the call premium. Okay. Now, for a large change in the stock price, you should incorporate the gamma like convexity. And you remember the convexity. For convexity, we do what? Half C del y square. Actually, that half C del y square is coming out of the Taylor series. Similarly, even in the case of options or derivative, the change in call option would be like duration into change in interest rate. I will read it as delta into change in stock price plus half convexity del I square, half gamma del S square, right? If there is a large change in the stock price, it is coming out of the Taylor series. Okay. Similarly, for change in put, it would be delta into change in the stock price. Definitely this delta is going to be negative. So a negative symbol will come, half into gamma into del S square. You don't have to put a negative symbol. It itself come as negative because the delta of put is going to be negative. However, this section is going to be positive because gamma is always positive. Okay. Now, delta is nothing but also called as hedge ratio, and there is also a hedging mechanism that is called as a delta neutral hedge strategy that you can construct with the help of this delta if you know the delta. Now, what is delta? Delta is the change in call price due to the change in the stock price, right? You can say is C2 minus C1 upon S2 minus S1, or C final minus C initial upon S final minus S initial, basically change upon change. Just remember the discussion of binomial tree. Assume you have a binomial tree of one period. Stock price was 100 and the up move factor is 1.2. So it is moving in the up node by 1.2 into 100, 120, and it will be divided by 1.2. So it would be 83.33. Now, what is the payoff of call option if the exercise price is 100? It would be 20, it would be 0. You have to calculate the delta. This is the payoff of call, the value of the call or the payoff of the call. When the stock price is moving from 83.33 to 120, the value of or the payoff of call is moving from 0 to 20. Can you calculate the delta? Yes. Delta is change in call upon change in stock. The payoff of delta is moving from 0 to 20 and the stock price is moving from 83.33 to 120. What is the change? 20 minus 0 upon 120 minus 83.33. That will give me a value of 0.5454. And this is what the delta of the call, and it is also called as hedge ratio. Now, why it is called as hedge ratio, we'll discuss this in a different manner that is generally written in the book. We'll try to understand it with the help of delta neutral strategy. Now, hedging with delta neutral strategy. Assume you have a portfolio of 10,000 stock trading at 55. Call option is selling at rupees 5 and has a delta of 0.70. Create a delta neutral portfolio. When I say create a delta neutral portfolio, you have to make the delta of the portfolio equal to 0. What does it mean? It means that the delta of the portfolio is 0. That means if the stock price changes by 1 rupees, 2 rupees, 3 rupees, there is no impact on the portfolio. How many stocks we have in the portfolio? 10,000 stock. What is the delta of a stock? What is the delta of a stock? It's 1. Why it is 1? What is delta of a call? What is the delta of the put? What is the change in the call premium, or what is the change in the call value due to 1 unit change in stock price? That is the delta of call. The delta of put, what is the change in the put due to 1 unit change in the stock price? Okay. I'm asking what is the delta of stock? Then you will say, what is the change in the stock price due to 1 unit change in stock price? I am dependent on myself. So that is the delta of stock, which is 1. If I change this by 1 rupees, I will change by 1 rupees, right? So the delta of stock is 1. So what is the delta of the whole portfolio? 10,000 into 1. That is the 10,000 delta. Now it is given that delta of call is 0.70. So if I buy a call delta is positive or negative? It is always positive. So if I buy a call, if I be long, my delta is what? Going to be positive if I buy the call. However, if I become a call seller and sell the call, the delta move in opposite direction. I will have negative 0.70, negative 0.70 delta for one sell of a call. I have to remove 10,000 delta. I have to make it 0. So if I keep on selling the call, definitely I will have more negative delta that will compensate 10,000 positive delta plus X amount of or N numbers of call I will sell minus 70 equal to 0.70. So actually this X will come as X into 0.70 equal to minus 10,000. So X is equal to 10,000 divided by 0.70. So the value is coming as 14,285. I need to sell 14,285 call to make a delta neutral portfolio. So if I have 10,000 stock in my portfolio and if I sell 14,285 call, then this portfolio have zero delta. Okay, now next, similar portfolio. Now I will make a delta neutral portfolio with the help of put. Assume 10,000 stock. Now put option is there and the delta of the put option is 0.40. Create a delta neutral portfolio. Now if I buy a put, the delta of put is always negative if I buy it. So it is 0.40. But if I sell a put, the delta will move in opposite direction for me. So the delta of put is going to be positive. Okay. So I have positive 10,000 delta. What should I do? Should I buy the put or sell the put? I have to buy the put because I want negative delta so that it can compensate for 10,000 positive delta. So x into negative 0.40 into 0. So x is equal to 10,000 upon 0.40. So 10,000 divided by 0.40, that will give you 25,000 put. I have to buy 25,000 put in this portfolio to make my delta neutral portfolio. So if I have 10,000 stock and 25,000 put buying, then this will have delta of portfolio equal to 0. Now, what is the benefit of delta of portfolio equal to 0? If the stock price changes by 1 rupees, 2 rupees, 3 rupees, nothing will happen to this portfolio. That is the beauty of the delta of delta neutral strategy. There's a problem with the delta neutral strategy. Let's understand. Assume that stock price is increasing. If the stock price increasing, now tell me what will happen to the delta. This delta will increase to 0.80. If the delta increases to 0.80, whether you want more number of call selling or less number of call selling, because now the number of call that is required is 10,000 into x into 0.80. So basically you need less number of call selling. So actually 10,000 divided upon 0.80. So now you only need 12,500 call selling. So actually you already sold 14,285 call. So you have to buy the difference. The difference, actually you have to buy more call so that you can nullify the effect of the difference of 14,285 and 12,500. So what I'm trying to highlight that as the stock price is increasing, the delta also changes. And because of that, this is actually not a kind of a static hedging. It is a dynamic hedging. You always need to check whether the stock price is moving a lot or not. If the stock price is moving a lot, then the delta neutral strategy does not work. And therefore, you need to go for something which is called as delta gamma neutral strategy. Now, we'll not get into the delta gamma neutral strategy because it is again a very complex strategy. But the step of that strategy is first you make the gamma 0, then you make the delta 0, right? So this is the way you move into the delta gamma neutral strategy. Okay. So if the stock price increases a lot or decreases a lot, the delta does not remain constant. So your delta neutral strategy is not a static strategy, it's a dynamic hedging strategy. You need to keep on buying, selling, call and put. For example, even in the discussion of put, if the stock price keep on rising, the delta of put will become what? Lesser, 0.20. So delta of put will decrease. So if the delta of put will decrease, then you have to buy more number of, now you have to buy 50,000 put. So actually you have to buy more 25,000 put. So actually it is not a static hedging strategy. What is a static hedging strategy? You applied a hedging strategy and you are sleeping at your home. Actually in this strategy, every day you have to see whether the delta of the portfolio is equal to 0 or not. because the delta is not constant. Why the delta is not constant? Because if the stock price is not changing by a very small amount, if it is changing by a very large amount, then the delta is not constant. It will change because the range of delta is between 0 to 1, and the delta will change and the strategy will not work. So therefore you have to move to something else that is called as delta gamma neutral strategy. So what is gamma risk? Stock price changing abruptly, leaving otherwise delta neutral portfolio unhedged, right? If the stock price changing with a huge amount, if there is a lot of jumps in the stock price, this strategy will not work. Now, what is Vega? Now, Vega, as we already discussed, what is the rate of change of call or put premium due to 1 unit change in the volatility? That is the standard deviation of underlying asset, which is the stock price. And we know that option buyers loves volatility, whether it is a call option buyer or a put option buyer. We are not getting to the discussion of why option buyer loves volatility, because it is a very detailed discussion which we did with a multiple different scenario that why option buyer loves volatility. What it only means that if volatility increases, option buyers loves that because the call premium and the put premium increases. What does it mean? It means that call premium and the put premium is directly related to option volatility. If the option volatility increases, call premium increases. If the stock price volatility increases, then option value increases. Basically, the volatility increases of the underlying asset, the value of the option increases. Therefore, option buyers loves volatility. So, what is Vega? The Vega is the rate of change of option premium due to 1 unit change in the volatility. So the formula for the Vega is what? The change in call premium due to 1 unit change in the volatility, keeping other factor constant. Similarly for put, the Vega is what is the change in the put premium due to 1 unit change in volatility. And whenever volatility increases, put premium increases. Whenever volatility increases, call premium increases. So Vega is always going to be positive, whether it is call, whether it is put. Option buyers loves volatility. So if you're buying the option, the Vega is positive for you. But if you're selling the option, then Vega will move in opposite direction because call seller does not loves volatility. He hates volatility, and option the underlying asset volatility moves in opposite direction for option seller. Option buyer loves volatility. Option seller hates volatility. So if you're selling the option, Vega will be negative for you. If you're buying the option, the Vega is always positive for you. Now let's talk about the graph of gamma and Vega. Now, graph of gamma and Vega both look like normal distribution. It is not actually normal distribution in the terms of whether it is in the money, at the money, out of the money. So it is being said that the gamma of the option and the Vega of the option, we know that this is going to be positive for call and put both if you're an option buyer, but it is highest at the money. Why it is highest at the money? Because at the money the uncertainty is pretty high, because if it fall by even a cent, even a paise, then it is out of the money, and if it is increasing by 1 cent, it is in the money. So at the money the uncertainty is very high. So therefore the rate of change of call premium due to change in volatility or due to the change in delta is pretty high. Therefore gamma is highest at the money and Vega is also highest at the money. However, extremely out of the money and extremely in the money, both gamma and Vega is very near to zero. Now theta, we all know that option buyer loves volatility. And more time you have, it gives more time or room to volatility to play. So volatility and time goes hand in hand. So option buyers loves volatility. It also means option buyer loves time. Okay. So what we are trying to tell in theta, that what is the rate of change of call premium or what is the rate of change of put premium due to 1 unit change in time. That is what is theta. So theta has to be positive because option buyer loves volatility, and volatility increases with time, or volatility get more room to play when time is larger for you. So volatility and time goes hand in hand. Okay. But we all know the time is always decreasing. So therefore, to respect the nature of the time that it is always decrease for you. The maturity is always decreasing for an option. We call theta as negative. Otherwise, theta is should be considered positive, because if time increases, call premium increases. If time increases, put premium increases. But we all know that the time always decreases for call or put for anyone in the planet on the planet. Okay, so theta is always negative, considered negative, because time always decreases. Now, theta is always highest just before the expiry. Why it is highest just before the expiry? Because the value of time is highest when there is no time. Just very similar to your examination. If you have no time left for your examination, you understand the value for the time. Similarly, in the option, when the there is no time left for expiry, then people understand the value of the time, and therefore time gets a lot of weightage when it is not there, when it is not left, and therefore the theta is highest very near to the maturity or very near to the expiry. Now the last discussion is left is about rho. Now rho is what is the change in call price due to 1 unit change in interest rate, which is risk-free rate, or what is the change in put price due to 1 unit change in risk-free rate. Now, whether it is positive for call or whether it is negative for call, negative for put, let's understand. We know that the call value is equal to S0 ND1 minus x upon e to the power RFT into ND2. I'm not writing ND1 and ND2. Understand, if the RF increases, this section will decrease, because if RF increases, denominator increases, the whole value decrease, and it is falling after negative sign. So the call value will increase. So if RF increases, the call value is increasing. If RF decreases, this whole value will decrease, this whole value will increase, and this is coming after the negative. If RF decreases, this whole value, this value will decrease, this whole value will increase. It is coming after negative, and this will be a higher value, so the call value will decrease. So RF falls, call value falls. So I can say the rho is positive or greater than 0 for call option. If I write for put option, then it is x upon e to the power RF into t minus S0, definitely ND2, ND1, I am removing it. Now if RF increases, this section actually decreases, because if RF increases, denominator increases, the whole value will decrease. So if RF is increasing, the value before the negative is decreasing, so the put value is actually decreasing. Now again, if RF decreases, then denominator decreases, this whole value will increase, so put value will increase. So can I say that there is an inverse relationship? So rho of put is going to be, the rho of put is going to be negative, because when the interest rate rises, call premium also rises. When interest rate fall, the call premium also falling. So there is a positive relationship. But in the case of put, when the interest rate is rising, put premium is falling. When the interest rate is falling, put premium is rising. So there is a negative relationship. Okay. So that was for put. So we completed all the discussion in the Greeks.